Okay, Maths Masters. Funny story, I just recorded this video not even 30 seconds ago and I forgot to turn the microphone on. Hooray for me. So, here we go again. This time, hopefully, it'll be quicker. So, what I'd like to show you real quick is how we graph parabolas. Now, remember that parabolas are simply a way of visually representing a relationship within an equation. Now, remember that whenever we write an equation, it is actually expressing a relationship between numbers. Okay, very basically, 1 plus 4 equals 5. The relationship is that this side is equal to this side, right? Okay, so all equations are expressing some sort of relationship. Okay, so there are two different types of relationships that we've looked at briefly. We briefly touched on linear relationships, and then we looked at our non-linear relationships, which is where you get the parabola from. Now, our parabola is an interesting shape because it comes about as a result of a certain part of the equation. Okay, and that is this little part of it here. So when the x value is squared, then we get a y value that doesn't go up in a straight, nice, linear, even fashion. Okay, let me demonstrate with two examples. So the first example that I'm going to give you is just a simple old linear relationship. You've probably done so many of these before. Y, so the y-axis is going to be equal to the x, let's not erase, the x value multiplied by 2. So let's say 2x, okay? Now, let's plug some numbers into this and see how it pans out. So let's put a number 1 in first for the y value because that's nice and easy. Sorry for the x value. So when our x value is 1, we're going to get an equation that looks like this. Y equals 2 times 1, right? Okay, which is going to be equal to 2. Okay, so what's the y value? 2. So let's find that point on our graph. Now let's do it again. Let's plug in the number 2, shall we? Y equals 2 times the value of x, which is 2. Okay, 2 times 2 equals 4. So already you can see this is going up at what appears to be quite a predictable rate, but let's keep testing it to see whether or not this relationship will result in a nice straight line. Okay, let's plug in the number 3 for our x value. Equals 2 times 3 is equal to 6. So when the x value is 3, the y value is going to be 6. Now, have a little look here at what's happened. Each time our x value has been multiplied by 2, the y value is going up at a nice, even, predictable rate. So we could end up plotting this as a line. Okay, and this line could potentially go forever and ever and ever and ever, depending on how many numbers you wanted to end up plugging into the formula. Okay, now the key difference with parabolas is that squared element in it. So let me show you a quadratic equation, just a simple one, where we solve for the y value. So let's say y equals x squared. This is probably the most basic, common parabola formula that you will see. So let's plug some numbers in, shall we, and see where it takes us. Now, because I already know by looking at the square that this is going to be a parabola, I'm actually going to start by plugging in a negative number because that's going to help me a lot when I get to the other side. All right, y is equal to x, which in this case is going to be 3, negative 3, squared. So that's negative 3 times negative 3. Negative 3 times negative 3 is going to be 9. Okay, because remember, negative plus a negative, or negative times a negative, is a positive. So let's come up, find our value, and there it is. All right, let's do this again with the x value of negative 2. Y equals negative 2 squared, which is negative 2 times negative 2, equals 4. So when our x value, as we put in, is negative 2, our y value is going to be 4. Okay, now you can already see that this is quite a big jump. So I'm interested to see whether or not it's going to make the same jump. Now, negative 1. Y equals negative 1 times negative 1. Now remember what we're plugging this in for. We're plugging this in for that x value right there. These are all of our x values, okay? And we're squaring them each time. 1 squared is 1, so easy peasy. There we go. So as you can already see, looking at this graph, it is not going up. Our y values aren't going up at that nice predictable rate that we had before. There's already what we call an inequality or a non-linear relationship happening here, okay? All right, let's keep plugging numbers in. Let's put in the number 0 for our origin point. 0 squared is 0. Okay, now we're going to repeat it with the x values of the positive side. 1 squared is going to be 1. Okay, 2 squared is going to be 4. 3 squared is going to be 9. Okay, so I've just flown through these very quickly, but now we can see what has ended up forming, and the shape that we have created is a parabola. So I hope this helps you see, and if you get stuck, here's my suggestion for you, and if you're finding it just a bit too overwhelming, and what has been really helpful and what I've seen you all do very successfully is creating this table of values, okay? And that just helps you keep track of the x and the y values so you can plot it nicely, okay? So you'd put your x on the top, your y on the bottom, and if your formula was the y value is equal to x to the power of 2 plus 4, then what you would do is you would solve. So you'd put your numbers in the top here, all of your x values in the top, whether it's negative 3, negative 2, negative 1, 0, negative 1, etc., etc. Whatever those x values are, you're going to put them in the top row, and then you will solve for the y value here and put in all your y values. Okay, I hope this helps, and I hope this gives you a bit of a hint, a little bit of a flying overview at what we've been doing.